So we've looked at the product property, and the power property with exponents. And now we're going to hit some more things. First of all, if you have a negative exponent, what does that mean? And you, again, have some experience with this. A to the negative 1 is the same thing as 1 over a. It's a reciprocal. Or a to the negative b is 1 over a to the power of b. If you have a negative exponent in the denominator of the fraction, 1 over a to the negative 1, in a sense you move it from the denominator to the numerator, and when you make that transition, the exponent becomes positive. So this would be a to the positive 1, which is just a. Okay. Or same idea with b. You can move this to the top part of the fraction and get a to the power of b. And in general, your answers should never have negative exponents. So when your final product, never have negative exponents. You always want to make it positive. And the way you make it positive, just move it to the other side of the fraction. If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. Okay. Second thing is the quotient rule. So how do you divide? What do we say about multiplying? When you multiply two things that have the same base, what do you do with the exponents? Add them. So if we're dividing two things with the same base, what do you think we do with the exponents? Subtract them. Good. And it matters which way you subtract them. So on number 5, for example, this is a to the, should I go b minus c, or should I do c minus b? B minus c. So numerator minus denominator in that order. Okay. And so on 6, here we have an exponent outside. A's to the power of 1, b's to the power of 1, and so we get a to the power of x over b to the power of x. But here, be careful, the bases are not the same, right? So can we subtract the exponents? No. The bases have to match in order to subtract the exponents. And so we could just leave it like that. So let's take a look at just mixing some things that we've already done. So number 7, 2 to the power of negative 3. Anybody think they know how to do that one? Ashley? Okay. Good. Good. So there's two things we had to do there. We had to get rid of the negative exponent by moving it from the numerator to the denominator, and then just evaluate what is 2 to the 3rd power. That's 8. Okay. 8, 7 to the negative 2. Someone else? Someone else? 7 to the negative 2. Yes. Not 14, but good job. Very good. Kaylin, right? Thank you. Very nice. Number 9. Someone else? Turner. Nice. Okay. Look at 10 and 11. Should those both give you the same answer? You sure? Just asking. I want you thinking about it. What's the difference between them? Exactly. So in number 11, that negative 2 power only belongs to the x. In number 10, that negative 2 power belongs to both the 3 and the x. So there is a difference, so you should get a different answer. Okay. So in 10, this is the same thing as 1 over 3x in parentheses squared, which is 1 over what? 3x squared or 9x squared? 9x squared. So you got to square the 3 and you got to square the x. Okay. On the other hand, 11, 3 is in the numerator, it stays in the numerator. But the x to the negative 2 is going to move to the denominator, and that's your answer. 3 over x squared. Number 12. Here we have an exponent, and so the x is going to be cubed, and the 3 is going to be cubed, and so it's going to end up being x cubed over what? What's 3 cubed? 3 times 3 times 3 is 27. Careful, it's not 9. 27. Okay. I'm going to keep doing the easy ones with you. I'll give you the hard ones later, okay? So this next one, we're cubing. And so everything's going to be cubed. So the 2 is going to be cubed, the x is going to be cubed, the 3 is going to be cubed. And so what's the numerator going to end up being? Okay. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Can we reduce that fraction? No. Uh, 14. 4x squared is going to give us 16x squared over 12. Can we reduce that fraction? Yes, we can. And I could divide by 4 and get 4x squared over 3. Could I have reduced it in the beginning? Could I have taken the 4 and the 12? Could I have done that in the beginning? If you did, you get a different answer. So no, you have to deal with those exponents first before you reduce. Okay. All right, try 15, 16, and 17 on your own. Fifteen, 16, and 17, yes.
Careful. Yeah, the 2. You have to square the 4 and 3. Working on it. Got an X up here, X on there. You can work with this.
I'm seeing a lot of good answers to 15, 16, 17, where I'm starting to see not as easy. I don't know if I've seen the right answer on 17 yet. Unless I did it wrong. It could happen. Okay, so let's go over these. Number 15. Rosario, what'd you get? Perfect. Good job. So 16 over 81x squared is what you want for 15. There's multiple ways to do these things, okay? But I'm going to just demonstrate one way here. So you need to work on the exponent on the outside first. So 16x squared in the numerator, 81x to the 4th. Does that 4 come from 2 plus 2 or 2 times 2? Times, good. And then 16 and 81 can't reduce, but whenever you have a common base, you can simplify that. So what I do is I look at which one has more, which one has a larger exponent, and I have more x's in the in the denominator, and so I'm going to end up with x's in the denominator because I have 4 of them there, and so I subtract in the denominator instead. Okay. You could leave it, if I subtract in the numerator, it'd be 2 minus 4, and then I'd end up with a negative 2, and then I'd have to bring it down. So you could do that as well. Okay, but that's your answer, 15. 16, Jace, what'd you get? Very good. Okay. Now there's an important thing to note on 16, and you may want to jot this down. There's a difference between a negative exponent and a negative number. Okay. Before you learned about negative exponents, if you had a negative number in a fraction, you didn't move it to the other side. You left it there. Okay. It's only the negative exponents that do thing. That's the part you move up and down. So negative 4 is just a negative number. You do not move this up to the numerator and make it a positive 4. You leave it there. Okay. So working through this, the numerator is going to be 4x to the 6th. Okay. I have one negative exponent, y to the negative 2. That needs to move. So I move it to the numerator. I have something in the numerator and the denominator with the same base. They both have base x, so I need to subtract those exponents. I have more in the numerator, so I'm going to do 6 minus 2 in the numerator. And I cannot move that negative 4. That stays there. Okay. And then 4 divided by negative 4 is negative 1. I could reduce that fraction. X to the 4th, y squared. And you don't need to write a negative 1 in front. It's just a negative. So that's where that's come from. All right, number 17. I didn't look at everybody's. I didn't see this answer. Some of you did. Okay, I didn't see everybody's. But again, there's a couple ways to do 17. But first thing is you're distributing a power of negative 2. And so notice how I did that. I just multiplied all the exponents. So most of the exponents on the inside were 1s. So I just got 4 to the negative 2, x to the negative 2, y to the negative 2, 3 to the negative 2. The only one that I really had to multiply was a negative 2 times 3 and get x to the negative 6 here. Everything had a negative exponent, so just flip the whole fraction over. And it gets rid of the negative exponents. And then work through that. 3 squared is 9, 4 squared is 16. And then I could subtract these. X to the 6 and x squared have the same base, so I'm going to subtract those exponents and get 9x to the 4th over 16y squared. All right, 18 looks even more complicated, but it may not be. So try 18 and 19. Give it a try. No new rules, there's just a lot of things to think about in these problems. What's 5 squared? Is that 5 to the negative 2 or 5 to the positive 2?
5 to positive 2.
What's that?
20 is off.
Okay, so write that one, okay?
similar. Let's see. Okay. See what you got. Okay.
All right, so um, 18, right? Aiden, what'd you get? 18. 25a. Did you have a to the 6 or just a? A to the 6 over b to the third? Perfect. Okay. So when you have a lot of things to do, right, there's a lot of steps to take. Sometimes it matters what steps you take first. Sometimes it doesn't. But in this one, you have to deal with the exponent outside the parentheses first. And so that's what you see me doing here. The 5ab is all squared. And so I make that 25a squared b squared. The negative b cubed is squared. So that negative squared, it becomes a positive because negative 1 times negative 1 is positive 1. And b cubed squared is b to the 6. So that was my first step. After that, you have a little freedom. You can divide or you can multiply. One doesn't have to come before the other. Division and multiplication are kind of equals. I chose to multiply and then divide. So I did 25 times 3. Some of you may have canceled the 3's out. That's dividing, right? So I did that, and I did a squared times a cubed, gave me a to the 5th. B squared times b gave me b to the 3rd. Got rid of my negative exponent. Just move that a to the negative 1 up. And then also dividing now with the b cubed and the b to the 6 by subtracting exponents. And then I finally divide the 75 and the 3 or reduce that fraction. And I get 25 a to the 6 over b to the 3rd. Okay. And 19, what you get? Very good. 4 over x to the 7th, z squared, z to the 4th. Okay. Lots of negative exponents. They all move around first. Get rid of those negative exponents. It's a good way to start. And then multiply and divide. You get to your answer. All right, last two, number 20, 21, try them out again. Yeah. Mm-hmm. Yeah.
Are you still working on it, or you got it? Okay. Gotcha. Nice. Only one thing though. Forgot. So that 3 is to the -2 power. And then it kind of disappeared here. Did you get it? Dennis, did you get it? Still working on it? Which one you working on? 20? Okay. Olivia? So this step, is it gonna, oh, hold on. All right, let me show you real quick and then see you guys later. Here it is. 21, guys, anything to the 0 power is 1. Right? And then 20, take a look at that.